going on? No. No, sometimes we get bugs that freak students out in here. So, so you all have this handout for section 1.1, and it's this will be as typical a day as any. Generally, my lectures are doing problems, and generally, every even problem matches up with an odd problem, means they have the same skill. So like today, I'm going to lecture, and I'll probably do all the problems between 2 and 20 evens. Tonight, that you're supposed to do problems 1 through 19 odd. I would suspect, like if you try to do problem 5 and you get stuck, if you opened up my video and watched what I did for problem 6, you should be able to basically just follow. They should have the same skills. And this is going to be the same for my tests too. When I see a review problem, the test problem should have the same skill. So these two problems, to me, if problem 6 was a review question, problem 5 would be a test question that I think would be a legal test question to ask. That wouldn't be unfair. So the first 8 problems ask me to factor out the greatest common factor. A lot of times when we go to factor, we make 2 parentheses. That's factoring trinomials. Generally, you get 2 parentheses when you have 3 terms. Sometimes you get 2 parentheses when you have 2 terms, but that's not always the case. When the instructions say factor out the greatest common factor, that implies that there's either all the terms have the same letter, or there's a number that divides evenly into each of the terms. And my goal is to find the biggest number that divides evenly into each of the terms, or to find the letter that they have in common and write it in front of a parentheses. So I'm going to write an equal sign down. It's nice math, but it's not horribly wrong if I don't put it there, because what I write is going to be equal to the line above it. When I look to find my greatest common factor, I look to see if both the terms have the same letter. They don't, because the 12 doesn't have an X, the 6 does have an X. So what I'm going to write in front of a parentheses is not going to have an X, because both terms in the original problem don't have an X. But I'm going to write a number in front of the parentheses, and it's going to be the biggest number that divides evenly into 6 and 12. And that's going to be 6. So what's your name? Bryce. Do that again? Bryce, beautiful. With a Y? Yeah. Sorry. Good. See, sometimes I'm funny and I don't even know it. Sorry. I don't know. I can't spell. Sorry. So, yeah. So 6 is the biggest number that divides evenly into 6 and 12. So I'm going to write a 6 to the left of a parentheses. And inside the parentheses, I'm going to keep the sign from the original problem, the sign between the 2 terms with a minus. Because the 6 doesn't have a sign in front of it, I'm going to keep the minus sign. And then I have to decide what to put in front of inside the parentheses. And it's supposed to be easy, but maybe it's not. X first. What I'm going to do is, in my head, I'm going to divide each of the numbers in the problem by 6. The first 6, when I divide it by 6, it turns into a 1. Technically, the number I need in front of my X is a 1. But generally, if there's not a number written in front of an X, the 1's assumed. So I could have an X, or I could have a 1 in front of the X. Both would be correct ways to start off my parentheses. And then after the minus sign, you get a 2, because 12 divided by 6 is 2. So these are both correct answers. This is probably the better answer. But it wouldn't be wrong to have the 1 in front of the X. I don't need to do any more, but I can. If I want to, I can always check. To check, you just want to multiply back out your answer. So I take my answer, which is 6 times x minus 2, and multiply it back. If I multiply it back and it comes out to be the original problem, then I've done fine. So for this particular problem, to take my answer and check it, I'm going to take the 6 that's to the left of the parentheses, and multiply it by both terms inside the parentheses. So I'm going to go 6 times x and 6 times minus 2. Here I use a dot for the times. Now I'm going to use a parentheses for the times. A dot and a parentheses both mean times. For the 6 times x, I really can't multiply them. The best I can do is show that they're being multiplied by writing them next to each other. I really don't need the times sign, so I'm just going to leave the 6 and the x next to each other. And the 6 times the minus 2 is a minus 12. If I look at the original problem, and I look at what I get when I multiplied it out, it's exactly the same, so it's properly checked. What would be wrong to do is to get answers. If somewhere's on your page, if you're working ahead of me, you wrote x equals 2, x equals 6, you did bad things. The answer to this problem is not x equals 2. You don't set the parentheses equal to 0. So I'm done. This is the answer, and this is a common mistake. Because you remember something from high school or beginning algebra that is right in the right context, but not in this context. If you did something like this, you took the factors 6 equal to 0, you said x minus 2 equal to 0, and then all of a sudden you didn't know the correct thing to do here, and you wrote down 6, and for the x minus 2, you add 2, and you wrote down 2. If you wrote an answer like this, x equals 2, x equals 6, that's wrong. You only get numerical answers when the problem has an equal sign and when it's equal to 0. So here, for these particular problems, I'm just going to factor and stop. I do not set the factors equal to 0. So you're not going to get numerical answers. As a matter of fact, the only time you're going to get numerical answers is when the problem has an equal sign. If I was doing today section 1.5, if you look at section 1.5, every single problem in section 1.5, I see an equal sign. When a problem has an equal sign, that's when you're going to get numerical answers. So any of these, like an answer like x equals 6, x equals 2 would be a reasonable answer for a problem that had an equal sign, specifically equal to 0. But because the problems in section 1.1 don't have equal signs, it's completely wrong. And if it was a test question and you factored beautifully and got it factored to 6 times x minus 2 and then did the extra, that extra is wrong. Because I'm not trying to find out where this thing equals to 0. It turns out that 6 is wrong just in general. We'll get to that when we get to those kinds of problems. 2 would be the only correct answer if there was an equal sign. So when there's not an equal sign, you factor and stop. If you factor and set the factors equal to 0, you're doing something that's wrong, because I'm not trying to find out where this thing equals to 0 because there's not an equal sign. So this is just factor, stop, check if you want to check, but don't do any more than that. It's a huge deal on the test in terms of this is a place where you can lose a ton of points, because if you insist on setting every problem equal to 0 and getting numerical answers, then you'll lose points on a lot of problems. So 4 is similar, but it has 3 terms. Sometimes when I have 3 terms, I want to get 2 parentheses. None of the problems in section 1.1 do I want to break down to 2 parentheses. All of the problems in section 1.1, I just want to start off and write a parentheses, and something to the left of the parentheses is the greatest common factor. And this particular problem, I'm going to write both a number and a letter to the left of the parentheses that I inserted. What's the number part? 5, because 25, 20, and 5 are all divisible by 5. So I'm going to write a 5 to the left of my parentheses. And because each of the terms has a y, I'm allowed to get a letter to the left of my parentheses. In the first problem, because the 12 didn't have an x, I didn't get a letter to the left of my parentheses. But when every term has a letter, that letter needs to be written to the left of your parentheses. And what exponent does it get? It gets just y to the first. You want the smallest exponent. Here's 3 y's, there's 2 y, and there's 1 y. You want the smallest amount of y's, which is 1 y, or just y to the first power. So 5 y is going to go in front of my parentheses. I'm going to carry the signs down. The minus sign and the plus sign are going to stay where they're at. And then first, I have to turn the 25y cubed into something different. And it's going to be 5y squared. To get that 5y squared, for the 25, I divide it by 5. 25 divided by 5 is 5. There were 3 y's, but I took one of them out, so I'm left with 2 y's. I'm going to write that as a y squared. And then in the middle, I'm going to get 4y, because 20 divided by 5 is 4. I had 2 y's. I took one away, so I'm left with 1y. And that gives me 5y to the first. And then it's tricky to figure out what goes to the right of the plus sign. If you didn't put your signs in first, you might stop and be wrong. But there needs to be something after the plus sign. Just 1. Because when I divide the 5 by 5, I get 1. I had 1y, I took it away. So there's no y left there. So it's just a 1. And because the original problem had 3 components, when I factor by removing the greatest common factor, my answer has to have 3 components in the parentheses. This actually doesn't factor what's in the parentheses. It's prime. When we get into section 1.3, we'll learn again how to factor stuff like this. In this particular section, we don't need to break the squared into 2 parentheses. Let me go ahead and check. Do these colors even look at all different on the board? No, it's too bad. Purple's my favorite. So anyways, for checking, I'm going to take the 5y that I put in front of the parentheses and multiply it by each term inside the parentheses. When I do the first multiplication, and then checking is optional, but it'll guarantee you of a right answer. This is my answer, and I don't really have to go further. I'll multiply the first pieces. When I do the first, I multiply the numbers together, and the 5 times 5 multiplies to be 25. I have 1y, and I multiply it by 2 y's. That gives me 3 y's. Because this is 1y and 2 y's, and somehow you add the exponents when you multiply with letters, and that's review, but it's also review that we'll do later in the semester. So that 25y cubed comes back to me. The second multiplication, I multiply the 5 and the minus 4, and you get a minus, so I write the minus sign, and then a 20. And then I multiply y times y and get y squared. So that gives me the minus 20y squared, which is part of the original problem. And the last multiplication, both terms are positive, so I put a plus sign. Anything times 1 is itself. 5y times 1 is 5y. I can compare my checking to the original problem because they're exactly the same. My answer is correct. So every problem in Chapter 1 that asks me to factor, if I'm patient, I can take my answer, multiply it back out to get the original problem. If I multiply it back out and it doesn't come out to the original problem, then I made a mistake. So 6 is another just greatest common factor factoring problem. What I'm supposed to do is make a parentheses and write something to the left of the parentheses that is the greatest common factor. Then I have to, hopefully it's review and it's easy, but maybe it's not. Anybody feeling ultra confident today? What's your name? Tara. T-A-R-A? Huh? Okay. Cool. All right. So Tara, what is it? What should I write in front of the parentheses? X. Because each term has an X. I need to have an X in front of the parentheses. And I don't get a number because there aren't numbers in front of the x cubed and the x squared. There'd have to be numbers like 3 and 6 in order to get like some sort of factor of 3 out. And then inside, I'm going to carry my signs down. And then what's the rest?
X squared minus x plus 9.
Yeah. So from each of the pieces, I just take an x away. The first piece had 3 x's. I'm left with 2. The second piece had 2 x's. I'm left with 1. Notice I didn't write an exponent. It wouldn't be wrong had I written an exponent in the middle, but it's not necessary. And then from the last piece, I had an x. I took it away, so I'm not left with an x. I'm not going to check every problem because then I'll run out of time, but that's the answer to that. The inside of the parentheses, it turns out to be prime. Tomorrow we'll learn how to refactor when we have trinomials to figure out, what signs and how to go about factoring. But there isn't any 2 parentheses factoring in today's homework. So again, I'm supposed to write a parentheses. It'd be nice if I wrote an equal sign, but not horrible if I don't. Then I have to decide what I'm going to write to outside the parentheses. Y is good, but not enough. What's your name? What, Monica? Monica. That I could spell. Yes, Y is appropriate, but not enough. It's because when you're factoring out letters, you want to take the like here's 3 Y's, here's 2 Y's. I need the smallest number that the letter occurs. Since there's 2 Y's here, I need to factor out 2 Y's. If I just factored out 1 Y, I'd have 2 Y's left here, 1 Y left here. Both the pieces would still have Y's. So when you're factoring out with letters, you need to get the smallest exponent that they have, or the least number of the letter. In problem 6, 1 was the least number of x's that occurred. That's why I only had 1 x out front. In problem number 8, 2 was the least number of y's that occurred. That's why I need to have 2 y's left out front. I'm going to carry that minus sign down, and then what's going to go first in my parentheses? 3y. The 3 doesn't get altered because I didn't factor out a number. I had 3 y's. I took away 2. I'm left with 1 y. So I'm going to write a y next to my 3. I don't have to have an exponent. If I wrote an exponent, it would be a 1. And then the trick is to know what to do after the minus sign. A 1 is perfect. If you factor out something completely, you can't leave the spot blank. If you factor out identically something that was in the problem, you leave a 1 behind. If you just wrote 3y without the 1, that would be wrong. So here, basically, I'm dividing by what I factored out. Y squared divided by y squared is 1. So I took the y's away, but I have to leave a 1 behind. And again, since I only have 7 minutes, I'll skip the checking. But this right here is the best answer I could have for problem number 8. So those are standard greatest common factor factoring problems. 10, 12, and 14 asked me to factor out a -1. Not the most important skill ever, but it's a nice skill to remember. So for problems 9 through 14, I'm asked to factor out, it says a -1. I could have just said a negative from each polynomial. So if I look at problem 10, this is a sane question to ask. When I look at terms or problems, if a negative is written first, it's common to ask you to factor out a negative or a -1. And so what each of the problems between 9 and 14 want me to do is they want me to take a -1 or just a plain negative sign without the 1 and write it in front of the parentheses. These have the same meaning. A negative next to a parentheses without a sign is an implied 1 next to that negative sign. Inside the parentheses, I want to write something so it would multiply back out to be the original problem. And anybody remember or know how to factor out with negatives? Amanda? Lacey? Yeah. Switch the signs. Beautiful, Aaron. Yeah. So if you're factoring out a negative, you're going to change the signs. This sign was negative, so now I'm going to have no sign because it would look odd to switch a negative to a positive and write a positive first. And this negative is going to turn to positive. So I'm switching the signs. I'm switching a negative to a plus, but a plus written first is generally not written. Both of these would be correct answers, depending on whether you want it to have the 1 or not in front of the parentheses. So factoring out a -1 is something that's sane to ask when the first term has a negative in front of it. And when you factor out a negative or a -1, you flip the signs. If I wanted to check this, it's easier to check the left version than it is the right version. To check the left version, I'd multiply the -1 times the 3x and the -1 in front of the parentheses by the 5. When I multiply negative 1 times 3x, I go positive times a negative is a negative. 1 times 3 is 3, so I get a negative 3x. And then 1 times negative 5 is negative 5. Because this is identical to the original problem, I know my work is correct. 12 and 14, you certainly can factor out a negative how the problem is written. It's an odd question to ask if the problem isn't written with a negative first. So I'll do 12 two ways. 12, I'm going to factor out a negative 1 without rewriting the problem first. So the original problem is 5 minus x. I'm supposed to write a negative 1 in front of a parentheses or just a negative. If you don't want to have the 1, you don't have to have the 1. And then inside the parentheses, what would I write? So this 5 didn't have a sign in front of it, so there's an implied positive. You flip the sign from positive to negative. And then in front of the x, I'm going to get a plus. I'm going to flip when I'm factoring out negatives, I flip signs. And these are correct, both correct answers to the original problem, but odd answers. Generally, we only factor out a negative if the first term that is written is a negative. Another way to answer problem 12 is to rewrite the problem with the negative first, then factor. So this problem right here, 5 minus x, it's the same as the problem I'm about to write under it. I'm going to write the x first and the 5 second. The x in the original problem has a negative in front of it. If I'm going to rewrite it with the x first, the negative needs to stay first. The 5 doesn't have a sign. If I'm going to rewrite it with the 5 second, the 5 needs to have a plus. That's not factoring out a negative 1, but this problem, negative x plus 5, it makes sense to ask you to factor out a negative 1. Generally, we only factor out a negative 1 if the first term written is negative. Now I'm going to factor out my negative 1. I could write a negative and a 1 or just a negative. And then what goes in the parentheses after the negative 1? What goes in front of the x? What goes in front of the 5? Yeah, positive x. The sign in front of the x was negative. When I factor out a negative, I flip the sign from negative to positive. In front of the 5 was a positive. Now I'm going to flip the positive to negative. And you don't have to have the 1 along with that. So there's 4 possible correct answers to this problem, depending on whether you switch the order of the given problem and whether you write the 1 or don't write the 1. These all are correct. They're varying degrees of correctness. And the way I would do the problem is one of these bottom ways. It doesn't make sense to ask you to factor out a negative if a negative's not written first. Only have time for one more problem. Hopefully you can do the same for problem 14 as I did for 12. Let me do problem 18, which is probably the most complex in the bottom group of problems. So the bottom group of problems, numbers 15 through 20, says factor the opposite. When I see the word opposite, that means to factor out a negative. Of the GCF. So if I look at the problems in this next grouping, the instructions imply to me that there's a greatest common factor, like in problems 1 through 8, and they also want me to factor out a negative. So I'm going to write a negative sign and a parentheses, but not just a negative sign or not just a negative 1, because in addition there's a common factor, and I'm supposed to be able to look at the problem and know the number and the letter that make up the common factor. What's the number? 2. 42, 4 doesn't go into 42, but 2 goes into 42, 24, and 4. So I'm going to write a 2. A negative just because I was asked to factor out the opposite. And I also need a letter. A, because each of the terms have A's. I know I need an A. I need the smallest occurrence of A, and that's A to the first power. So I'm going to have a negative 2A. Now I'm going to get my signs in. This sign's going to flip to plus, so I'm going to write no sign for it. The plus sign's going to flip to minus, and this minus sign is going to flip to plus. Anytime I factor out a negative or an opposite, I get my signs first. If the first sign was negative, it's going to flip to plus, and you don't write a plus if it's the first thing in a problem. Plus signs flip to minus, minus signs flip to plus. So I have my signs fixed up perfectly. Now I need to get the numbers and the letters. So I'm going to divide each of the numbers by 2 and take away 1A from each. So the first thing I'm going to have is a 21, because 42 divided by 2 is 21. I had 5 A's, I took 1 away, so I get 4 A's. So 21A to the 4th is the first thing that goes in the parentheses. And then second, 12, because 24 divided by 2 is 12. A to the second, I had 3 A's, I took 1 away, I'm left with 2 A's. And the last piece, 2, plus 2, because 4 divided by 2 is 2. I had 1A, I took an A away, so I'm not left with an A. So the answer to this, hopefully that's somewhat readable, is negative 2A times 21A to the 4th minus 12A squared plus 2. And if you multiply that back out by checking, it multiply out to be exactly the original problem. It checks perfectly. So hopefully tonight, with this brief lecture, you can do all of the 19 problems that I assigned for homework in section 1.1. Beginning of class tomorrow, any of the problems that you didn't get, you can ask me, and I'll do them. And I'll let you introduce yourself to the class. Sit in a seat that you can tolerate long enough for me to learn your name, so that I can learn names, because I'm slow at that anyways. If you're feeling a little bit overwhelmed, you're more than welcome to come visit me in my office right now. I don't have a class for the rest of the day, for that matter. So you can come visit me, and I can help you get started so you don't get underwater on the first day. All right, thanks.